Alright, so here we are in Crewton Ramone's house of math. Twins having a good time. We're measuring so far. Yeah, because you're not going to have timeouts at all today. So here we just built all 25 combinations for 1 through 10 of the add-ins. And now we're figuring out how many sixes we're in. 24?
We have 1.
How many sixes?
2, 3, 4.
4 sixes and 24.
We have 1, 2, 3,
3 eights. So could I say 3 times 8 is 24?
Uh-huh.
Okay, that makes sense. Alright, so how about 4s? How many 4s do you think?
Let's see.
Grab some 4s.
1,
Grab some
2.
Oh, very good. She's counting out.
3, 4. 5.
Probably that's enough.
6.
Right. Good. Very good.
So there's 2 5s.
There's 2 4s for each 8.
Yeah.
There are 4s, not 5s.
Here I got 1.
Okay. Excellent. So now let's get crazy. What do you think? How many 2s would it be?
2. 2s?
You're gonna need a lot of 2s.
2.
She's counting 2s. Oh wait, how many 2s in each 4?
Wait. 2, 4, 6, 8, 10. 20.
Put them up, line them up and see.
10, 12.
What is math? Math is counting. That's all it is.
12, I think.
We're doing algebra, we're counting. We're doing third power algebra, we're counting. We're doing calculus, we're counting.
12,
Some things are... Now, wait, now can you see, look, can you see that each 4 has 2 2s? How many 4s were there?
3. 1, 2, 3, 4, 5, 6.
Wait, she's trying to line them up.
8, 9, 10.
Very good.
11.
Yep.
12.
12 2s in 24. 24 is a great number. It's got all these different ways you can build it. You need 12 2s. She got them all. In fact, you have more than enough 2s there.
Huh? Look.
Well, no, I'm saying here you got extra, and she got one over there. So you don't need 15 2s. You only need 12 2s. Excellent. So let's do a different number. Yeah, it's pretty fun, huh?
Let's see. 5.
You know what we could do? Oh, you want to try 5s?
Let's go.
5s will make a fraction. Let's see. Yeah, move it up a little bit. That will help.
There. Let's make about 1s.
1s. You know how many 1s? 1s would be 24 1s. Okay, so 5s. Is 5 going to fit evenly in there?
Oh,
So let's think about it and we'll count it.
no, they won't.
Okay, but that's okay. We can still count. 1,
I know, we could
2, 3. Wait.
4.
Yeah. Well, hold on a second. We'll still use the 5.
Wait a minute.
Yeah. 1, 2, 3, 4, 5. But we don't need that whole 5. How many parts of the 5 do we need?
So why don't we need to take away 1?
Okay. We need 4 out of the 5 parts to make it.
So we need
So we could say
4.
it's 4 and 4/5. You see that? 4 out of 5. Look, she grabbed the 4. 4 out of 5. Does that make sense? And then look over here. Look at the 10s. How many 5s in 10?
That's a fifth one. So that means...
Oh, look, and she's looking at her fractions. Yep, 4/5. There you go. Exactly. Good stuff.
So a 1 could fit there, so that means all we have to do is take
So we'd
away
have
this one.
4 with 1 left over, right?
So if a 1 could fit there, then we have to take away this one to fit it.
Right. So we would have 4 and 4/5 of 1.
What's the 3s now?
Okay, sure. Oh, that'll be cool. Let's take this one out. Let's see how many 3s will fit. I'm gonna guess. Let's get the 5s out of there. We'll just build the 3s. All right.
Wait a minute.
They'll fit.
These guys make a whole 3.
Yeah. Ooh, see? And look. See? Anyway, you cannot help but learn math when you play math. Make discoveries as you go.
One.
Now, how many of those 3s are there? Does 3 go in evenly?
Yeah.
Sure does. How many?
1, 2, 3, 4, 5, 6, 7, 8.
Good stuff. Alright, so let's write some of this down in our books.
Okay.
We just did 24 and counted out how many different numbers are in there. There's their pencils and books and okay, that'll be fun.
Do any birds go on there?
Not very often. The birds don't like coming over here because they know there's humans right here, and birds and humans they're scared of us.
I think I know why, because we're bigger than them, and sometimes
actually an eagle's sort of bigger on that.
And sometimes people hunt for birds.
Once in a while, though, there's a cardinal that comes and sits right over there and sings to me. It's very cool. You know those red cardinals? You ever heard a cardinal make them? Yeah, exactly. Okay, so they're writing all of the different combinations in their book. 24 divided by 6 is 4. 24 divided by 4 is 6, though. 24 divided by 8 is 3. 24 divided by 3 is 8.
Hi.
And then 24 divided by 2 was how many? She's writing it down. 4, 6, 3. Nope. Oh, just one. 24 divided by 12 is 2, but 24 divided by 2 is 12. And then we built the 12s over there in the last one. And then we could write it a different way. We could say 6 times 4 is 24.
Oh, so
Now we could say 4 times 6 is 24. Yes. That's the one you're missing. Good. Okay, so 7-year-old symbols here.
I wrote the date.
Excellent. Yes. Now, here we have some. We might be able to make some discoveries. We'll see. They're curious children. Now, how would I write 2 times 12? Do you know?
2.
Or 2 times 6, or well, not 2 times 6. 2 times 12, or 3 times 8.
What's the date?
The 5th.
3 times 8.
How do you write 3 times 8?
Well, you need 24 first, right?
First, let's put 3 times 4, and then make it equal to 24.
Okay, since it's the summer,
3 times.
I kind of forgot
the division sign.
How do you do? I don't know how to write the date now.
Where's the symbol?
Because it's summertime?
Yeah, and I got.
Where's the symbol for time?
Okay, so we have lots of symbols for times. Let's talk about that, because it's important to know where the symbols are. This, I could write it like this. I could say that I have 3 times 8 is the same thing as 24.
Yeah, because I plus it.
Now, here's the problem, is that when we use that symbol right there, let's turn it around. Hey, you pay attention. When I use this symbol right here, it looks like an X, doesn't it? So a lot of times in math, we'll do this. Those are parentheses, but when you're little, it takes too long to write all that stuff out. And that means the same thing.
Hey,
3
that's
across,
sort of like the thing
8 up.
that's the sort of thing we did in the cup game.
Yes. Okay, so 3 times 8, 24. But if I change it around and I say it's 8 times 3, it's still 24, isn't it?
Yeah. Because if you switch it around,
it doesn't change.
It doesn't change.
Right. All we did.
It's the same numbers, but if we switched it around and there's a new number, then.
Yes, if you change the number, yeah, there you go. So that's all we're saying is, look, if I have over here 3 times 8. Well, here's 8 times 3. 8 taken 3 times. There they are. And then if I go this way, that's, right, 3 times 8. And I could get a whole bunch of 3's out. But it's the same thing, right?
Yep.
This way or that way. Okay, excellent. You want to play a little bit of algebra, since we were doing algebra before? Or did you guys want to play fractions, or what did you want to do?
Freeze is this awesome.
We can write these down?
Yes, we need to write a few more. And you too. Let's
all the way to the bottom.
Well, all the way to all the different combinations that we just did.
So if there's...
Oh, look, and she's over here about to measure with
3 of these.
Right.
So there's
so we can see that
then there should be 3's, and then it's all 8, so it might be...
How many 3's do you think is going to fit there?
8.
Yep, you're correct.
Yeah.
Okay, so here, have some 3's. Now, even though we have symbols, and even though they just do it, you right, want to be sure. And the way to how is the best way to be sure? Build it yourself, just like she's doing. Oh, she's measuring its 7's.
Let's see, I just see a 3. Even if I can't fit.
All right, so 7's. is
I can't find
3
any.
7s and a 3.
Yeah.
Right? Look, there's more 3s there.
Okay, 3 more.
Right, so you know you have 8 3s there, right? Excellent.
Yep.
Okay.
Because all of those ones are 8, so there should be 8 3s,
Right.
and there's 3 of the 8, so there must be a 3 fit on there.
Right. Okay, good stuff. Get your book and your pencil out and write down some of the stuff. Yes, write down some of the stuff you did. Like your sister's doing over here. Okay, now see, and that's the other thing. If you change, you need to make sure you make that sign
How do I write it?
and X like this, so it's times, because otherwise it looks like plus, and if it's plus, then it would only be 11. Okay, good question. How do you write it? You write it 3 times 8. Or 8 times 3. And we need to know the difference. 8 taken 3 times, or 3 taken 8 times.
Okay.
And we have this thing called multiplicand and multiplier, which multiplication,
3 times.
which means nothing when they're 7, and don't waste your time,
8
adults.
equals.
Just need to know that if you multiply it 8 times 3, 3 times 8 is the same. But you need to know which is which when you're an adult.
3 times 8 is 8, right?
3 times 8 is 24. 8 times 3 is 24. Now, could you write 6 times 4?
6.
6 times 4.
Let's see. 4. Can I write 3, 8, 3,
Equals what?
8. 3 8.
Yeah, 3 times 8.
3 8. And there's 3.
So which?
3 8 will.
Just for fun, 24. So just for fun, this is 3 times 8, right?
Yeah, it's
3 times 8. And underneath you have 8 times 3. See it? There's a difference.
And it's the same.
It's the same number. Sure. Not with that in your book. Okay. So you're writing 6. She's writing 6 times. Good. Very good.
All together.
Excellent.
It makes.
Interesting the way you make
Wait,
it.
what's 8 plus 8 plus 8?
And she puts a question mark. What does it mean? What is it? You know.
Plus 8. I'm sorry.
And that's okay. Excellent. See? We got lots of things going on. Can you put 24 here?
So
we know 8 plus 8.
Altogether.
See, that's what multiplication is. That's adding up the 8s fast.
6 8 altogether. Hey, it's up there.
That's why I tell you.
It's switched around. It's not this anymore.
Oh, there you go. Ah, see? Discoveries made left and right. Now, so you see what we're doing? 3 times 8 just means 8 plus 8 plus 8, right? And then the other one, it takes a long time, would be 3 plus 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 3. That would be, right? That's why that would be 3 taken 8 times. That's why you want to learn your multiplication, because it lets you count fast.
3 8 4 8 5 8 6 8. So there's 6 8s altogether.
6 times 8. Oh, if you were gonna, yes, if you were gonna, yep, there you go.
3 8.
So now we could say 6 times 8.
4 8.
How much do you think 6 times 8 would be?
Huh?
6 times 8, how much do you think that is?
I'm gonna write that one down first.
Okay. So, you wrote your 6 times 4, how about 4 times 6?
Wait, 6 times what?
4
6
times
what? 8?
6 times 8. And see, 6 times 8, if you can multiply, it's super fast. I know what it is. But if you have to count it out, it takes forever.
Okay, 6 times 8 is,
Count them.
maybe 6.
Can you count by 8s? Can you count by 3s? Can you count by, what can you count by? If you count by 1s, it's going to take a long time.
Well, to get these 2 free.
See, we bring the point home that multiplication makes it fast. Oh, see, look at that. Contemplation. Alright. We'll do more. Okay, so she's writing out 6 times 4, 4 times 6. What else do we have? What? 2s. 2 times what was 24?
Well, you just switch these around, so it's still 24.
Right, but we have 12, so we're ever at 2 times 12.
Oh.
Did you write it? No, you don't have to erase. That's good. We have 4 times 6 and 6 times 4, but 2 times 12.
48.
Excellent. What a fine job of counting that was. Do you see how long it takes when you don't know how to multiply? So we got to learn some patterning. We can count by 8s. 8, 16, 24, 32, 40, 48. Or if we just know 6 times 8 is 48. But that was a very good job. Okay, so let's do some other stuff. We can play with multiplication all day long. But let's do some algebra and stuff. And we got to get you to write a little bit more, okay? I want you to put some more symbols in your book. Yes, you. Excellent. It's unfortunate I can't have the camera rolling the whole time. We miss out on some good math discussions.
Okay.
Alright, so anyway, and then we moved on to some algebra. And what we're doing is x squared, 5x, and 6. Didn't need to do a 3-period lesson because they already knew.
And now we need a 6.
How is that 6 going to fit in there? I think we should get a different kind of 6.
A different...
Oh, 3 plus 3 is 6.
Yes, there you go.
You
could have also probably have gotten 2s.
Wait.
Okay.
And,
all right, so
and I do need those.
Alright.
And I can make it a different way too.
Now hold on a second. If you get out 2 3s, and then
I can make it a different way like this too.
Yes, good. Oh, she changed
Look, it's going to be
it.
the same.
Yeah, but it's still just going to be right. Now you got 4, but I want 6. So here's what we're going to have to do. Now can you see how those are going to fit?
3.
Yeah, need another one.
2 plus 1. Okay. 2,
Right?
4, 6.
My favorite thing about these twins is they insist on
That
making
looks
theirs
like a
differently.
rectangle. This looks like a big square.
But one side's longer than the other. Can you see that this side is x plus 3 and this side is x plus 2?
This way.
In fact, wait. I have a little man to help us count.
A little man.
Yes, here he is.
Oh, please, no Legos.
He's not a Lego.
Yeah, he is.
Okay. Put these guys over here.
Okay, which way do they go? This way?
No, it's fine. Either way.
Huh?
Didn't we just have this
What
conversation
does Lego do?
about it could be either one?
Put that there. Put that there.
All right,
Stop it! Try
Okay.
to put it back.
So look,
So do
count
I.
for me. What does this guy see when he goes this way? What does he see?
X,
Plus.
2.
Okay, and then over here, what does he see?
X, 2.
How many?
3.
3. There you go. Okay, get it and write it in your book. Quick.
What page?
And make a new page for algebra.
Come on.
Sure, if you want to.
X.
These details are important. Okay, so
So what do we write?
we write x squared plus 5x plus 6 is what we write. Here, write this. And then we write the factors like this. And see, this is what we were talking about earlier about the parentheses. Why we don't use an x to tell us that we're multiplying. X plus 2, x plus 3. That's hers. Now yours is different. Yours is the other way around. Yours is x plus 3 and x plus 2. Right? So make sure you, alright? And then you can draw a little picture. Make sure you draw the picture. The picture is very important.
What do you mean equal? What does it equal?
It means the same. It means that this is the whole rectangle and these are the sides. Isn't this 2 ways of talking about that same rectangle? This is the whole thing, x squared, 5x, and 6. And this is x plus 2 and x plus 3, which tells me about the sides. Right?
1.
So you're drawing a little picture. I need to see the factors too.
1. It's okay. 2.
Yep, it is okay. You guys are doing great. Okay, try to write your symbols more neatly. No, it's fine, but just try to write your symbols more neatly and a little smaller, taking up a lot of space on your book. But remember, they're 7, so it's okay. Give me a closed bracket there, please.
2,
Excellent.
3.
And can you draw a little picture there?
See?
Yes, I do. And now the only thing we need is your factors, which is x plus 3 and x plus 2, written out like this.
It's not supposed to be written out by that.
It's okay, you can put them side by side. That's what the equal sign means, it's the same. This and that are the same.
3. Yeah, but I'll just do this.
Yeah, so put it right there.
2. Do what?
Put the factors right there. Here, I'll help you. Just on this one, though. The next one you gotta do it yourself.
2.
X plus 3 and x
That's what equals?
plus 2. Yes. We're saying it's the same. We don't know what x is at the moment. We're just fooling around and playing with the rectangles. Right? I tell you the rectangle, you tell me the sides. This is the game we're playing. Later on, I'm going to tell you the sides, and you're going to tell me the rectangle.
I drew it wrong.
What did you do wrong?
I drew it wrong.
Oh, you drew it wrong. How can you draw it wrong? Just have fun. Wow, you're going to take up a whole page just for one problem? And the answer is yes, which is it's fine, but we could probably put a lot more work on one page. Alright, are we ready for a new problem?
Yeah.
Okay.
Not yet.
Alright. The only reason why she's ahead of you is because I did the work for her. You did a good drawing. Excellent, excellent. I like it. Good stuff. Okay, now here's the thing. You could make it simpler than that. You don't have to be like this. Just draw some boxes and lines. You don't have to get all artistic. Just simpler is actually better. Okay? It's fine. I mean, it's fine.
Mine is like the same.
Yeah. But simpler is better, okay? And it'll be faster too. You guys are doing great work today. You know what they're working for. You know what they're trying to get. They're trying to get a dip in a candy bag, I can tell. Alright, so let's do another problem.
I already have 5.
Mm-hmm.
And so take the 2's away.
Alright, so if you have 5, you need 2 more.
Okay,
So it's
2
right,
more.
right?
See, I need 12.
So x squared, 7x, and 12.
2, 4, 6, 8, 10, 12.
Okay. Well, let's see if they fit. If you just use 2's, do you think it'll fit?
I think so.
Okay. She's building hers.
How much do I need? 12.
12.
1, 2, 3, 4, 5.
Maybe not.
Yeah. So, well, it's good though. You figured out x squared, 7x, and 10. So if I gave you the problem x squared, 7x, and 10, you could do it. But I want 12. Oh, very good. Now let's see what happens. Go ahead. Oh, grab these. Yeah, I'll take that. Give you a clue. Oh, and her sister uses 3's. She's using 4's. And oh, look, it works still both ways. She's counting just to make sure. Excellent. So what are the factors?
Well, they fit, so it must be it.
Right.
But can this fit too? Because
Try it. Let's see. Let's see. Ooh, let's see. Let's see if it fits too.
Oh yeah, so I already did.
Oh, you see hers already. All right, even though it's a different shape. Okay.
Well, maybe I could do a different
No, that's good. That's good.
They're adding.
All right, so write it down in your book. What? Oh wait, before you can write it down, we need to count it. What do we have?
I'll do it on a different page.
Yes, that's fine. We have. What's this side? Going across? What does he see?
X plus 3.
X plus 3. And what does he see this way?
And 3x.
Wait. Just the edge.
X
Plus
4.
Plus 4.
X.
So x plus 3 times x plus 4. And draw me a... Very good.
Where's the fraction?
Oh, you want me to write it for you?
Yeah.
Let's see how it is. I'm writing it over here. X plus 3 times x plus 4. But you have to write it the other way because yours is x plus 4 going across. See it there? And this is x plus 3. So this is the across and this is the up. The first one is always the across. The second one is always the up.
How do you write it for me though?
Just write it. X plus 3, just like this.
Okay.
Okay. And draw me a little picture. I'll draw a picture too. Like this. And it's getting to the point where it takes too long to put all those little guys in the corner, but you could just write 12 if you wanted to. Alright. So.
I think this is longer than this one.
Right. So I could just do this too. I could just put 12. Alright? But however you want, I don't care. But draw me a little picture. And like I said, just draw a quick sketch. You don't have to get all artistic on me. Just draw. Excellent. Look at that. You can put your arrows in. Look at her. Oh. Good job. Playing with the symbols.
There's 3 of those. 3. And there's 4 here.
And let's do a few where we don't use symbols. We'll just build them.
4 and then
It'll be faster and more fun.
3.
And she's putting in her little dots. She's doing excellent. Alright, we're having fun. Alright, so let's do another one. I'm going to put x squared, 8x, and... How about x squared, 8x, and 15?
Okay.
Can you write that down? Actually, you know what? Let's not write any more down. Let's just build them and have fun. I'll write them here, and you guys don't have to write because it takes too long.
Come on, let's
Okay.
write.
All right. Well, if you want to, we can. So x squared, 8x, and 15. So all I'm changing is this and this. 8x now, and 15.
So there's 8, 7. Wait, so we had.
And now we got to put 15 in the corner.
Maybe I might leave this here.
Ooh, but.
No, fits.
Oops.
Doesn't fit.
Yeah.
This fits.
Oh, what'd you get? How many 3s?
So right now I did have 12 right here. So 12.
Mm-hmm.
5.
15.
Very good.
10.
Mm-hmm.
15.
Yeah.
And then she.
That was easy peasy.
All
What
right.
am I to do it?
Excellent. I'm glad they're easy
Up to
peasy.
50.
Yep. There you go. Please rate.
Do a harder one.
Okay. Do a harder one. All right. Coming up with a harder one in just a second. But first, write this one down. This is what we like. Right. Once the confidence is there, and once they know what they're doing, let's do a harder one. Let's do bigger ones.
Where's the contract?
Okay. Oh, we got to change this because it's not 3 and 4 anymore for sure. What were the factors?
This too.
Yes, that's got to change too. So I'm going to do that, right? And I'm going to put another one there. And I'm going to change that to 15.
Equal.
All right. So then what was it? What is across? On hers, it's x plus 3 across. And how many up?
Wait, is it for me? For me?
I'm talking about hers. Or yours, either one. Tell me.
X5.
All right, x plus 5. There you go.
No.
And on yours, it's x plus 3. Wait a minute. What's yours? Yours is x plus 5. And x plus 3. Unless you change it, you can change it around and make... Okay, fine. She's going to change the symbol, so it's easier to just erase the one then. Right? And that means, right here, that means multiplication right there, because we bumped these two things up against each other, right?
Wait, so x
Plus
and
3
less.
and x plus 5.
Do I put 5 right there?
Yes. Wait a minute. Do you? Is that what you have? X plus 5 and x plus 5? You have x plus 5 and x plus 3.
8.
Wait a minute. That's this. You're counting the x's. I'm talking about the dimensions. Over here, we have x plus... Look. X plus 1, 2, 3, 4, 5. And over here, I have x plus how many? Going up? Just the edge.
8, 9, 10, 11.
How are you getting 11?
I mean, this is 10, 11, 12, 13.
If we were in base x. Well, wait a minute. If we were in base 10, you're right. But we're in base x. So it's
8.
x plus how many? X plus
3.
3. So you have to write x plus... Aha. Okay.
So now...
Keep it in mind. Never wrong. Just getting more information. Every time. Just get more information. And
Wait.
draw a neater one than that. Here. I'll help you. Let's put this like that. So we make a square. Because we have an x square. And then we'll put these guys over here. 1, 2, 3. 1, 2, 3, 4, 5. Simple. Okay. So,
I got it right.
should we do a hard one? You ready for it? You ready for one that's more challenging?
3.
Okay.
Okay. All right. Hold on. So now what I did is I gave you. Oh, you only have 3. You're trying to put 6 in there. We only have 3. I gave them one where I have 2x squared, 5x, and 3, just for fun. Just
So
to
I
see if
make
they can
that.
do it. Well, that's the whole thing. Spend some time fooling around and see if you can get it. Now, first off, make sure you only have what it says. You can only have 3. You can't have 6.
Can you use the other one too?
Yes. Oh, she's gonna try and build it a different way. Excellent. I like it. Okay, we'll see what happens, and because it's gonna take a while for them to fool around with this, I'll bet you. But look, they're just having fun playing blocks.
I only met with one.
Very interesting though. I love the fact that you built yours like this,
You tricked me.
and she built. Well, I put 2x
Hey, let me
in
do
there,
2x
and she
again.
built hers like this. But we both got it after a bit of time. What's this wee stuff? You both got it after a bit of time. So now you can see that 2x squared plus 5x plus 3. Now comes the trick of counting it. On hers, we can see how many? 1, 2, what? 2, what do we call these guys?
X.
Cool, I
Plus how
can
many?
erase this my eraser.
3.
Yep, 2x plus 3, and over here I have just a simple one.
X1.
X plus 1.
Mommy.
Mama.
Excellent. And then over here, you had x plus 1 and 2x plus 3. Right? Okay. Last one. Record it in your book.
Record it in our
Record it in your books, and we're done. Man, that hour went by. Did that go by fast or what? It's amazing. Okay, today they were so good, they get a dip in the candy jar. No timeouts, no hassles. 100% work. All we did was do work.
Good for you guys. Mommy's very proud.